Hello everyone, welcome back to this online class. Today we are going to look at the fourth form of the integral, that is under hyperbolic and trigonometric substitutions. And our integral will be the integral of 1 over the square root of x squared minus a squared. You integrate that with respect to x. So how do we go about this? Or which substitution do we need to make? Remember, I gave you the trigonometric substitutions and the hyperbolic substitutions. So in this case, before even we decide on which substitution that we are supposed to make, remember our integral. If I factor out the a squared from the denominator, remember it is inside the square root sign. And so when you take it outside, it becomes a because of the square root. So this can now be written as 1 over a. I've explained why it is now 1 over a times the integral. So this will be the integral of now 1 over the square root. It will now be x squared over a squared, then minus 1. And integrate that with respect to x. So now you need to ask yourself, we need something minus 1, or a trigonometric function minus 1 gives you another function squared. Or you cannot ask yourself which hyperbolic function, when you subtract 1, you get another function squared. So I have eliminated, remember, we know that there are two functions we can use. Let me tell you how to incorporate the trigonometric function here and how to incorporate the hyperbolic function in the same problem. So here you can use, you can be able to work it out in two ways. The first way is you take note that 1, I'm going to write it, just a minute. We know that 1 plus tan squared theta is equals to sec squared theta. Let me show you how to go about it. That 1 plus tan squared theta should be able to give us sec squared theta. But I want what minus 1 gives me another function. So I must subtract 1. So I can decide to take 1. Can decide to take 1 to the right, so that I have sec squared theta minus 1 will give us tan squared theta. So this can be written as, remember this was a note, just explaining how to get the substitution. It was a note. So this can be written as sec squared theta minus 1 should be able to give us tan squared theta. So then what do we say? If I do the comparison, I have x squared over a. I'll write here x squared over a squared. That's x squared over a squared, sorry. X squared over a squared. Then we are subtracting 1. What should this give us? We are interested on the left-hand side, with the left-hand side. So you see, minus 1 is the same on the left-hand side. So you can as well say that x squared over a squared is the same as sec squared theta. So from here, you can say this, that x squared over a squared should be able to give us sec squared theta. And when you make x the subject, what do we get? Make x the subject. That should be very easy. If I make this the subject, I'll be able to get x is equals to a times sec theta. X is equals to a sec theta. So this is the substitution that you need to make. That is a trigonometric substitution. And when you differentiate x with respect to theta, what will be our dx? So when you find the derivative, you'll get that dx will be equal to what is the derivative of sec theta? That should give us sec theta tan theta. Sec theta times tan theta. And remember, we are differentiating with respect to theta. Remember, it was dx over the theta. So that's why I'm adding the d theta here, because when you cross multiply, you get something like this. So every time you make a substitution, you must also know how to get the corresponding differential. So you substitute this, you also substitute the x. There's another way. This maybe you can call this method 1. Excuse me. Method 2 is what we call the hyperbolic substitution. Again, ask yourself, what do we know? We know that cos squared theta, I can talk of method 2 before I can write here method 2. Method 2, this I could have written this as method 1. I've explained method 1. Excuse me. So method 2, I want to show you how to use hyperbolic substitution. So how do we go about it? We take note that cos hyperbolic squared theta plus, not plus, I said it's minus, and I explained that when I was talking about hyperbolic functions and hyperbolic identities. So this should be minus sine hyperbolic squared theta. That should be able to give us 1. But if you look at what we have is x squared over a squared is equals, no, minus 1. X squared over a squared minus 1. So I want minus 1. Just rewrite this identity so that you have something squared minus 1. So how do we rewrite this? I can decide to take 1 to the right, to the left, I mean, and this other one, the sine hyperbolic squared, you take it to the right. So what will we have? We'll have cosine hyperbolic squared theta minus 1 is equals to sine hyperbolic squared theta. You see, that's the form that I wanted. So I now do the comparison. Excuse me. I now do the comparison. So we'll have x squared over a squared minus 1 should be equal to something. So when you look at the left-hand side, you see -1 is common. So we can as well say that x squared over a squared is the same as cos hyperbolic squared theta. So you can now write this as x squared over a squared is the same as cos hyperbolic squared of theta. And so from here, if you make x the subject, you'll get x is equals to, of course, it will be x squared is equals to a squared times cos hyperbolic squared theta, then get the square root on both sides. So that will give you a times cos hyperbolic of theta. That is another substitution that you can make. This is now hyperbolic substitution. So what about the derivative? What will dx become? So when you differentiate, you get dx will be equal to, that will be a, because a is a constant. When you differentiate cos hyperbolic of theta, you get sine hyperbolic of theta. So look at my substitution and the corresponding differential. So when you have such kind of integrals, then you have two ways of evaluating it. Either you can use trigonometric identity or substitution, or you can use hyperbolic substitution. So whichever you find easier for you will give you the correct answer. So you substitute x is a cos hyperbolic of theta, and dx is equals to a sine hyperbolic of theta. That is in method 2. In method 1, we said you can say let x be a sec theta, and the corresponding differential, that is dx, is equals to a sec theta tan theta d theta. I have left the theta here, so let me add it. I left it. There should be d theta here, don't forget. I'll add d theta because it should be a times sine hyperbolic of theta times d theta. So I rub this that I had written so that I insert d theta. Somebody might ask, why am I adding d theta? Because we are differentiating. Dx over d theta is equals to a sine hyperbolic theta. And then you make dx the subject to get that. So that is the other substitution. So I am going to look at one or maybe two examples just to be able to illustrate this concept. So you can have example, and in the examples you are told or you are asked to evaluate the following integrals. Let's say part A, let me write, you are asked to evaluate part A, you are told the integral of 1 over the square root of x squared minus 9. Integrate it with respect to x. So you see, this is the form of the integral that we are talking about. I am going to show you the two methods, how you can go about them, but in maybe an exam scenario, just choose whichever is easier for you. The answers you're going to get are the same. So method 1, we call it method 1. Let's say we are using hyperbolic substitution. Hyperbolic substitution. So in this method, you let x be equal to Remember, it was a cos hyperbolic theta. In this case, our a is 3, then cos hyperbolic theta. So I must know what is my dx. When you differentiate x with respect to theta, you get dx over the theta. Of course, I'll cross multiply. So dx is equals to 3 sine hyperbolic of theta d theta. So substitute this into your integral so that we now have the integral of 1 over the square root. Now x squared, that will give us 3 cos hyperbolic squared theta. Of course, it is 3. So when you square 3, you get 9 cos hyperbolic squared theta minus 9. Then I can see this dx. The dx here should be 3 sine hyperbolic theta d theta. So in the denominator, 9 is common. When you factor that outside the square root, you'll get, of course, 3 times the square root of cos squared theta minus 1. So let me write, it will be 1 over 3 times the square root of cos hyperbolic squared theta minus 1. Then this times 3 sine hyperbolic of theta d theta. Now, you now need to ask yourself, what is cos hyperbolic squared theta minus 1? We said that is the same as sine hyperbolic squared theta. And because that is under the square root, when you take the square root, you get sine hyperbolic of theta. So we have 3 times sine hyperbolic of theta in the denominator. So the whole of that will cancel with the other 3 sine hyperbolic of theta. So that our problem is that of integrating 1 with respect to theta. And the answer here is theta plus c. Now that is our answer, but ask yourself what is theta, because you have to leave your answer in terms of x. So you need to make theta the subject, and if you look at where we defined our theta, we said that x is equals to 3 cos hyperbolic of theta. So I'm going to make theta the subject. From here, theta is equals to, of course, you take cos inverse after dividing by 3, the inverse hyperbolic cosine. So you write this as cos hyperbolic inverse of x over 3. That's what we get as theta. So that our answer here, I'll write this is equals to, we are replacing theta, so cos hyperbolic inverse of x over 3 plus c. Remember, c is the constant of integration. That is method 1. I tell you there are 2 methods. Another method, which we'll call method 2, is trigonometric substitution, and the one that you can use here is letting x be equal to a sec theta. So let me write that down. You can write this as method 2. That is on trigonometric substitution. So in this method, you let x be equal to sec theta, a sec theta. Let me insert a. Let x be equal to a sec theta. That is the substitution. Now, what do you think is the x? When you differentiate x with respect to theta, you're going to get the x being equal to a is a constant. When you differentiate sec theta, you get sec theta. Remember the derivatives of trigonometric functions? Sec theta times tan theta, d theta. I have told you why I'm multiplying by d theta, because it was dx over d theta. And when you cross multiply, you get dx as the subject. So you will substitute those two into our given integral. So how will the integral look like? It will be the integral of 1 over the square root of x squared minus 9 squared. So let's square x. When you square x, and let me ask you, excuse, our a is 3. So instead of writing a, I just write 3. So that is our a. So that will give us, and even here, you see, instead of a, I'm going to write 3. So x squared will be 9 sec squared theta. Then there's a minus 9 times dx is 3 sec theta tan theta d theta. You can simplify this so that in the denominator 9 is common, so that can be factored out. So the square root sign, so that we have 3 times the square root of sec squared theta minus 1. So this you can as well write as 1 over the integral of 1 over, you factor out 9, you get 3. Then we have the root of now sec squared theta minus 1. Then times 3 sec theta tan theta d theta. What is sec squared theta minus 1? That is tan squared theta. And because this is under the square root, it means it will be tan theta. So we have 3 tan theta in the denominator. And look at our numerator, 3 sec theta tan theta. So you realize that the 3 here will cancel with this 3. And the whole of this square root, because you have said that is tan theta, will cancel with this tan theta. So what do we remain with? We remain with the integral of, I can see the sec theta d theta. And if you look at the techniques of integration, what did we get when you integrate sec theta? It should give you natural log of sec theta plus tan theta. You need to look at the U substitution now to integrate sec theta. You do that via the U substitution method. And don't forget to write the constant C of integration. So we now have the answer, but you have to leave this answer in terms of x. So I have to replace sec theta I also must replace tan theta. And that you can get it from our substitution. Check where we defined our theta in method 2. In method 2, I can see that x was equals to 3 times sec theta. So from here, you realize that sec theta, because I want to make that as the subject, sec theta here is the same as x over 3. If sec theta is x over 3, what about tan theta? That is what you need to ask yourself. So for you to get tan theta, you know the identity that 1 plus tan squared theta is equals to sec squared theta. So let me write it so that I show you how to get sec theta. You need to ask yourself that 1 plus tan squared theta this should be able to give us sec squared theta. So I need to know tan theta in terms of sec theta. So make tan theta the subject. So this means that if I want to find tan theta, I'll now be talking of tan squared theta being equal to sec squared theta minus 1. And when I take the square root on both sides, I am going to get tan theta being equal to the square root of sec squared theta minus 1. That is tan theta. So our answer here, we go back to our answer. This was just a note. I can just bracket it so that you see what is happening. So we go back to our answer, and this answer can now be written as ln, a natural log of sec theta plus, instead of tan theta, we have said that the same as the square root of sec squared theta. Sec squared theta minus 1. And remember, there was a constant c of integration. So, and we have said here, we have said in our substitution that sec theta is equals to x over 3. So I'm going to replace that and finally get this as natural log of x over 3. That is sec theta plus the square root. When you square sec theta, you get x squared over 9. Then we subtract 1. And there's a constant c of integration. So look at these two methods. For me, I find method 1 very easy because it doesn't take a lot of time. Method 2 will consume some of your time, but just like I told you, choose a method that is easier for you. You'll still get the same answer. You realize that the answer we got in method 1, what was it? Cos hyperbolic inverse of x over 3 plus c. And in method 2, we are now getting the answers ln, or natural log of x over 3 plus the square root of x squared over 9 minus 1. You see, those two answers are the same. Because remember, in hyperbolic functions, I told you how you can express inverse hyperbolic functions as a natural logarithm. And when you express cos hyperbolic inverse of x over 3, you're going to get the answer that we have found in method 2. So thank you for watching. Don't forget to subscribe to my channel. Also, don't forget to share this video. You like it and you also comment it. When we meet next time, we look at other techniques of integration. Thank you all.